No questions? I have no problem whether you ask questions or not. But thing is, if you are not clear, then you ask. Then you surely ask, because there is no point that you are not following what we are talking and you are not raising your hand. You just unmute and speak. That's it. I'll handle. Don't you worry for anything. Don't you worry for completion of syllabus. Your only concern is, my only concern or your only concern should be that you should understand the concept. If you are having any problem, just raise your hand, ask questions, get the clarification. And if you think that you are a little bit hesitant in the online session, then you can speak to me offline, means after the class. You can send message on my mobile WhatsApp, and as I get the time, I'll surely ask you to call me or we can talk. So that depends how you handle that. I mean, when you approach me. So when you are not asking, I believe that you are clear. So some sort of commitment should be there. If you are not asking, I'll take this for granted that you have understood the concept. Is it okay? Akshay Rath is doing everything for the class. Great. So we are going back where we left last class. If you remember in last class, we discussed about descriptives and we talked about correlation coefficient and we also talked about significance of correlation coefficient. We discussed in detail in the last class that correlation is a degree of association. It takes, we call it Karl Pearson correlation coefficient. Its value is equal to -1 to +1. So it's a measure. It can be compared, higher degree of association, lower degree of association. For example, let's say between X and Y, the R is plus 0.30 and significant, asterisk I'm showing with significance, and correlation coefficient between X and Z is coming out to be plus 0.40, again significant. We will obviously say that the degree of association is high between X and Z as compared to X and Y. But the value of correlation coefficient is always between -1 to +1. It is neither less than that nor more than that. That's why we call it. It is comparable. It is always given, which you can. I mean, relative degree of association is something which we can say. So that is what we have calculated. Then we went for two more very important descriptives, mean and SD. Mean was representing the value of the variable. SD was variability of value in the distribution. So when if you remember last class, I was talking, let's say we have got one variable X, and in statistics or econometrics, all the variables are always studied on a lot, LOT lot. So lot has got some size, let's say small n. Then you generate values of X. X is the variable, and you have got up to xn. You arrange x1 to xn in the ascending or descending order. I've called that, this is known as distribution. And every distribution can be understood with the help of three descriptives. One is the representative value, which we call measure of central tendency. And then I said measure of dispersion, and I said measure of shape. So this is nothing but mean, which I'm showing by x bar. This we usually show by sigma. One of the best measure of dispersion is standard deviation. It measures the variability, how much variability is there in the values of the variable. This is representing the value. So all the values are being represented by the mean value. And shape, I said that different things are possible. As later on I talked about, let's say, symmetry, about the mean, and then whether the distribution is flat or have the high pickedness. So accordingly, you have got leptokurtic, this is basokurtic, and this is platykurtic. These things you will be studying in detail in other courses. I am only picking up those material which are relevant for econometrics course. I can't teach 2, 3 courses altogether. So I'll concentrate on whatever is relevant in my course, and you can be rest assured that whatever is required to be taken up from other courses will surely be taken up. Nothing will be left out. Keeping this in mind that you would have studied that in some other course. Whatever I require, I'll surely take it in my course itself. So this is what I have discussed when I talked about descriptive statistics. And I told you that before we do any advanced analysis, it is always great to surely have descriptive statistics ready. Descriptives tell a lot of things. So what happened that advanced statistics or advanced data analysis clubbed with descriptives reveal many more things which are not possible unless until you have descriptives with you. So advanced analysis coupled with the descriptives add a lot of value to the whole data analysis. This is what we have discussed. Then we partly discussed about the result of regression. If you remember, I have talked about that there are 3 templates: descriptive, regression results, and discussion of output. If you look at this, suppose I knock it out, I remove whatever we have discussed in the last class, and start from the scratch again. If you look at this, you find it a little complicated because there are many things which are there which some of you might be coming across first time. What is happening exactly? Why we are doing this much? So let's talk about why we are doing this much. If you look at what we are doing in this caselet, if you remember the caselet, we had the fitness first caselet, and the caselet we discussed that we are interested in finding out a model, develop a model to relate weight with age and height of the healthy people. So practically, if I try to show you that then we are interested in something known as y is equal to beta 0 plus beta 1x1 plus beta 2x2, where y is weight, x1 is height, and x2 is age. And what we are interested in building a model of y so that if I happen to get somebody having a certain level of height, having certain age, then what will be the ideal range of weight which that person can have with the given height and given age. So that is the model which we are interested in building. If you look at this model, what are the unknown things? When I say what are the unknown things, if you look at the data, which is here obviously, we are having data of certain 10 people. We have data of weight, height, and age of 10 people. So when we are interested in making a model, we are practically interested in these coefficients. These are the coefficients which becomes important for us. We are interested in these coefficients. If somehow we can calculate these coefficients, our model is ready. And as we have discussed earlier, that suppose I am running, I'll run the regression, and Yeah, here I am having the my data set ready. So I'm interested in running a regression where dependent variable is weight and independent variable is height and age. I have to simply run it. I have my regression. All of you can see, and if you remember, these three are the coefficients. If I'm just interested in coefficients, then I can easily, find out the value. I can say y is equal to minus 39.08 plus beta 1 is minus point, no, 0.73 x1, which is obviously height, and then we have minus 0.26 in x2. So what we are having, we wanted to build a model. We were interested in building a model, and we have got a model. So what we have estimated, three coefficients. Now one question, follow-up question for you. Why we do not stop our exercise of building the model here? Why are we interested in such a complicated description of result of regression analysis? Why I'm taking so much pain, or what we are going to discuss so many things? Why is it required? Question for you. You need to answer. Yes. Yeah, please respond. Unmute and speak. Come on.
So to perfect the model,
To
perfect the model.
you want to have a perfect model. Any other
Yeah.
logic? Any other considerations?
So
Feel
to get
free
more,
to
so to get
get
more reliable results,
more reliable. What do you mean by more reliable?
so more understanding of the variables and how they affect each other.
As far as the data is concerned, we have estimated. So this estimation is not going to change. Whether we do this complicated discussion or not, this whole discussion, whether we do or not, because here, here we whatever we are going to have, coefficients are here. I'll be having my coefficients here. So this will not change. Whether I do anything or I don't do anything, my information is going to be same. So my question still remains, why am I interested in doing such a complicated exercise? Tanushi, estimation will be done the way I have done. What else to be done when you say more reliable model?
Sir, maybe to understand the impact of each variable on the outcome.
But look at this model. We are having two independent variables, height and age. That was the practical model which we were interested in building. We were interested in knowing a model where weight can be predicted using height and age. And that we have ready. That model is ready. My question is still remain unanswered. What else? Why we are doing this complicated exercise? Very important question.
Maybe because sir, we want, as we say, as people said, accuracy. So we want to know that there is a
No,
number, but then how much
I'm
it
not denying
varies.
the fact that accuracy, but as far as the estimation of model is concerned, please pay attention. Estimation, these coefficients are not going to change. You understand? These coefficients will remain same. No way I'll be changing the whole exercise. This estimation of the model will remain same. This I'll not change under any circumstances. I'll only talk about something else, but these estimation will remain same as long as I have got this data set. My results of beta 0, beta 1, beta 2 are not going to change. So still you can further try to answer the question. Yeah, feel free.
So is it because we have considered a small sample and we need
Yeah,
to?
So,
yeah. Now you are talking nonsense. Yeah. Nishan, tell me. Nishan, carry on.
sir,
Please
if I
go
may,
ahead.
what I was thinking is that the reason is The reason might be because we want to predict the future. So for example, if I want to estimate the market, estimate demand for a product or anything like that, I have the past data, and now I need to create a model so that using that past data, I can predict the future demand, forecasted demand for that product. So this is one use of
So
this
you want to
model.
be, okay, perfect. Both the views are okay. Now listen to me. Both of you are talking sense. What is happening? No, both the points I'll write down. We have one issue. One major issue is that we are using sample data. And practically what we are doing, both the answers are correlated. You are using sample and you want to tell the story about the population, means you would like to use the results derived from sample for population. And obviously when you say you would like to predict or forecast, what you are saying, the purpose of this, again, that you want to use the model so that you can talk about the population. So same thing, limiting factor is sample. Are you with me? Limiting factor is sample. We have just a sample of our argument's sake, as in our example of caselet, we have 10 is the sample size. And population, let's say we are talking about people of Pune itself, then roughly we can say 60-70 lakhs. Now see, we want to use the information derived with the help of 10 people on 60-70 lakh people. Is it so easy? Is it so, can we do it so casually? Is it some magic that we have estimated a model and what we are saying that this model is good enough? And what we have done, this model is estimated with the help of 10 people, and we are saying this model is so strong that can be applied on population. No, absolutely not. And that is the clear-cut reason. Just because you are using sample data to tell the story about the population, you need to tell the user of the model the whole story. Whole story means, if you look at, I have made this template. Yeah, look at this. The whole story means I have to tell to the user of this model what is the strength or weakness of coefficients which I am going to estimate. Means here what I have estimated, beta 0, beta 1, all these need to be beta 0, beta 1, beta 2, all these coefficients, whether they are good, bad, how they are impacting, significance, and the relative importance. Suppose I have got beta 1, beta 2, then the relative importance. All these things need to be discussed and told to the user of the model separately. Similarly, I need to tell to the user that what is the strength of the whole model. When I talk about coefficient analysis, I'm only interested in individual item, beta 0, beta 1, beta 2. But when I'm saying I'm talking about whole model, then I'm talking about whole model per se, not the individual items. So I have to tell to the user again. Then this issue is also, some of you might be coming these three words first time. What is happening? These art, or I mean practically the science or the inferential statistics which we are using here to estimate beta. I mean, look at here, let me explain to you again what we are doing. We are having beta 0 plus y is equal to beta 1 x1 plus beta 2 x2. What is happening? When we are running the model using 10 people only, then we are estimating something like that. I'm differentiating beta 0 and beta cap, beta 1 x1 plus beta 2 cap x2. So please pay attention. Beta cap is the closest possible value of beta 0, because this model is basically meant for the whole population. This is for whole population. But just because I do not have population at my disposal or data of population for at my disposal, so what I'm making use of, or I'm building this model using only 10 people. So I have got certain values of the coefficients, like beta 0 should be as close as possible. Beta 0 should be as close as possible to the, so beta 0 should beta 0 estimated should be as close as beta 0, beta 1 estimated should be as close to as possible beta 1, actual when I say then population. After all, I want to use the model, so beta 2 estimated should be as close as possible to the actual beta 2. Please pay attention, this is the model which we are interested in making. But just because we have this data, so we have landed up with this model, which is having limitation. I mean, how we can be so sure that these estimated betas or beta caps are going to be close to, or they are a good replica of the actual betas. So this exercise is done by a particular method. We call it optimum least square method. Optimum least square is the method. If I just try to draw it, suppose here what I'm saying, for every, I mean, here X is drawn, here Y is drawn. So I've got 10 pairs of X and Y. I've got 10 pairs of X and Y. And let's say randomly I am placing it. So all 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say these are the 10. So now what I'm doing, I'm trying to establish one line in such a way that as I'm trying to, this difference, this distance, these distances, if I, individually I can calculate these differences. So this is the imaginary line which I'm conceiving in my mind, or let's say computer is conceiving in such a way that all these 10 distances from the actual point to this imaginary line is such that if I call all these let's say yi, and I'm saying it's square, I mean this I'm saying this is u for that matter. So from this line, from the actual point to this line, I'm trying to, summating it, I 1 to 10. This I'm trying to reduce. I'm trying to have as less as possible. So this value I'm trying to reduce it, whether in my mind or software is doing, so that this y estimated, beta 0 estimated plus beta 1 estimated plus beta 2 estimated, here x1, here x2. So these values of beta 0, beta 1 and beta 2 are estimated keeping this thing in mind, that from the actual point, the distance to this imaginary line, which is represented by this equation, is having the least distance. So in a way I can say the regression line which we are estimating, I repeat, this estimated line would be a line of best fit in such a way. And the method which does this whole exercise is known as OLS method, optimum least square method. I'll repeat, this is known as optimum least square method, OLS method. Are you with me, all of you?
Yes,
Yes,
sir.
sir.
Yes, sir.
So when I say that I am using a method which is known as OLS to do this whole exercise, then I am assuming that this model would have been practically estimated in the best possible way. So this line should truly be line of best fit. But this may, this may not be that simple as it is sounding right now. It is based upon certain set of assumptions. And certain rules. So if I try to abide by these set of assumptions and certain rules, then I have to do practically two things. I have to test for testing of significance or testing of hypothesis. So this is the first thing which I have to do. Every time I am estimating one regression model using sample data, and before I use the model built using sample data for population, I need to be assured whether the coefficients, as long as the coefficient analysis is concerned, all the coefficients should surely undergo testing of significance. Unless until it has gone for testing of significance, I'm not sure whether the estimated coefficients are good enough as per the rules of OLS to be used for population or not. I do not know. So this testing of significance, just because I'm using sample data, becomes mandatory. And this testing of significance does not only confine to testing the coefficients, but it also goes for model interpretation as well. So testing of significance is necessary for both for model as well as for coefficients, because I'm using the sample data which I want to use for population. Second thing, as I was saying, that we are using OLS method which is based upon certain set of assumptions. So we have also to be very sure that all the assumptions on which OLS is based, which we are using to estimate the coefficients beta 0, beta 1, beta 2, should follow the assumptions. And that's why, if you look at here, we have got something known as diagnostic testing. Diagnostic testing is nothing but trying to fulfill the requirement. This requirement is being fulfilled. This requirement is being fulfilled, set of assumptions, whether they are holding true or not. And just to ensure that, I've got diagnostic testing. There are three things. I'll discuss about them in a little more detail as I reach there. And then we have got something known as parametric stability. Because when we have estimated the model, I do not know whether this model is correctly specified or not. Please pay attention to the word which I am using. Under this parametric stability, I am saying that the model should be correctly specified. It means to know the impact on Y, to know the impact on Y, I have picked up the correct set of variables. Are these two variables enough, or any one of them are superfluous, or I need to have something third variable? These things are practically estimated with the help of this parametric stability. I hope my point is clear. My point is clear. So model specification is studied or tested with the help of parametric stability. So if you look at the whole discussion of output, I need to check whether my coefficients are significant or not, because I'm using sample data which I want to apply on population. I need to test testing of significance for the individual coefficients. I need to test the individual, I need to test the whole model for testing of significance. And I've got one or two more things which tell me whether my model which I have built is good or not good. I mean, fitness of the model is also, or possibility of error is also measured or studied with the help of model interpretation, the second head in this output discussion. Diagnostic testing is required so that the set of assumptions are holding true or not. Then we have got, just to ensure for assumptions, we have got diagnostic testing. And then I said whether I have taken correct set of independent variable to study the dependent variable, or to have a model of dependent variable based upon these independent variables, whether the set of independent variables are correct or not. Are they less, are they more? That exercise is known as testing the specification of the model, and that we study with the help of parametric stability. And the last item in the output is that we need to practically go for calculating the forecast value or predicted value, and we need to have the range also. So that whole 5 things become output. I will only say up to this, at this juncture, only this, that once you learn this, then this is the best possible way. I mean, there's nothing beyond it. This is complete in itself. So this whole 5-point discussion of regression analysis is complete in itself. So by the time we have finished this, you will find that you have really learned something very big, which is that usually not available to most of you. I mean, I can say around 30-40% of you would have surely studied regression analysis before, but I can partly say that most of you would have not got the exposure of presenting the same regression analysis using these 5 heads. And I'll also say that there's nothing beyond these 5 heads. Within this, I can further refine it if I have to dig it further. I want to make it more perfect. But at your level, these 5 things are already good enough to serve the purpose. Now I go back to you. Feel free in asking the question. Anything which you are not clear. I insist, unless until you ask, I'm not sure whether you are understanding me or not. Yeah, please go ahead. Somebody was saying something. Yeah.
I wanted to confirm that OLS model we use for population, not for a certain number of people. No, like you told, there's one we take Y cap and we take Y.
Okay.
So OLS is used for Y cap or Y, like entire data or a limited number of data.
Listen, OLS is a method. So when we run OLS takes data from the sample, and with the help of OLS method only, we estimate beta 0, beta 1, beta 2.
Okay, sir.
So this is the method which is practically helping to estimate the coefficients, beta 0, beta 1, beta 2. And with the help of that, we are getting a model. When I'm putting, instead of y cap, I'm saying that my model is estimated. As long as I'm putting just y is equal to beta 0 plus beta 1 x1 plus beta 2 x2, I'm giving you one model which has not been estimated. But when I put the value of y cap, it means the model is estimated. I've got estimated value of beta 0, beta 1 and beta 2. So that is the difference when I use caps, not the simple y. I hope I have answered your question. Feel free in having any follow-up question if you have. Anyone else?
Sir, I have a question.
Please go ahead.
Yeah, sir, I understood that testing of significance part for the coefficients. So for example, you have beta 1, beta 2, you have the variables like height and age, and you want to use that to predict the weight. So that testing of significance, I understood that, because if it is deviates significantly from the mean of the population, then we can say that is significant and we need to consider that for our model. But then you show that output file. In that, the second point you said that model testing, you also, apart from testing the coefficients, you also test the model.
Yeah.
So that part I didn't, can you repeat that? I didn't understand how you test the entire model separately.
Suppose in your class there are 35 students. Individually are having the, let's say, any assessment, any, let's say, assignment or a quiz. So individually you have got the assessment done. Your scores are with you. I know individually how you are performing or your friends are performing. And then collectively also I'm interested in knowing what is the collective performance of MBA first year 2022 batch. So collective as well as individual. So that is what the differentiation is when I say that individual coefficients are tested and the whole model is tested.
Okay. And do we have separate tests for that?
Yeah,
like
yeah.
the
The whole story
two-tailed
is
test?
different. Just wait. I'll disclose everything to you, and that will be done in the best possible way. I mean, there's nothing beyond it. This is the final words.
Okay. Thank you, sir.
I'm open to more questions. Feel free in asking even your smallest possible doubt. Don't worry. Be extremely selfish. It is your learning. Just look at your learning, whether you are clear. What your friend is thinking, don't bother about that. Ignore that issue. Just think about yourself. Are you clear? If you are not clear, please ask. Yeah, somebody, okay. Somebody was talking that testing of significance. Let me again throw some more light on testing of significance. Please pay attention. All of you listen to me very carefully when I say testing of significance. Testing of significance has got practically nothing to do as such from the population value. Rather, we are doing the testing of significance or hypothesis testing just because we are using sample data, generating some results, which we want to apply. Please pay attention. We want to apply on population. That is my problem, or problem of doing the testing of high significance or hypothesis testing. I have sample data, I have got some result from the sample data, and I'm interested in applying on population. So I need to do it. This is the first basic concept which should be clear to everyone. Testing of significance or hypothesis testing is done just because I'm using sample data which I want to use for population. So I have to be ensured whether my, let's say for argument's sake, Bj estimated, Bj I'm representing whether B is beta 0, beta 1, beta 2 is as close as possible to the actual Bj. So this is the exercise, this is the logic of exercise. This is the first point. Second point. Whenever we are doing any testing of significance or hypothesis testing, these two terms are used interchangeably, so I'll call it testing of significance. We need to have pair of hypothesis, or rather I'll say that one hypothesis which is known as null hypothesis. And if you have remembered, I have told you there are two types of null, null of no difference and null of no association. There's nothing third type of null. So when I say null, before doing any testing of significance, I need to specify. And please understand what is the null when I'm testing any coefficient. Please pay attention what I'm doing. My discussion is now only for coefficient analysis. I'll go step by step and I'll request you to ask questions if you are not clear. We'll go step by step very slowly. So right now when I'm talking this discussion, I'm doing this discussion of testing of significance in the context of coefficient analysis of a regression model. Coming back, H0 in this case is equal to beta j, a general hypothesis is going to be there, which is equal to 0. Or alternate, I'm calling alternate is going to be H1, and I'm saying beta j, bj is not equal to 0. This is my pair of hypothesis for testing of significance for coefficients. So this is the null which I am having at my disposal, beta 0. So what I am claiming, there is no population story per se. We are doing it just because we want to use sample data as a result for population. But I'm not saying that I'm taking anything from population. Those ideas which you had studied during your statistics course are used in different context. Right now, context is different. Don't mix the two contexts. So right now, context is I'm doing testing of significance for my coefficients. And for coefficients, so in a way you can understand that pair of hypothesis depends what you are testing, or the context in which you are testing. Right now, my context is I'm testing the significance or hypothesis testing for coefficients. So I'll be arranging everything accordingly. So right now, to test the coefficient, this is my pair of hypothesis. And my claim is, this 0 is claim. There is nothing to do with the population. What is the claim? Claim is that the beta z, remember I'm saying beta z, not beta z estimated. So what I'm saying, please pay attention. My discussion at this point of time is about this beta j. I'm using beta j estimated to tell the story about beta j. So just because I want to do this exercise, I'm doing this testing of significance, and I'm claiming that bj can be equal to 0. When I'm doing this, I'm going to either accept this or reject this using sample data. So this hypothesis that bj is equal to 0 and bj is the value of the actual model which we were aspiring to estimate. This is the model which we are aspiring to estimate. But just because we do not have data, so we have estimated this. And just because we have estimated this, so we are doing the testing of significance. But when we are doing the testing of significance, we are saying that this is 0. Assume that this is 0 and test using this data, sample data. And if you find that using sample data, either we are going to accept this, that bj is equal to 0 or bj is not equal to 0. In a way, I can say that my hypothesis testing is that x1 is, please pay attention to what I'm saying right now. I'll write it again here so that you have more clarity. When I'm saying this hypothesis, let's say, let me give one particular hypothesis, H naught for, let's say I'm talking about B1 is equal to 0, H alternate B1 is not equal to 0. I have given J is equal to 1. And now what I'm doing, I'm testing that in this model, beta 0, please pay attention, I'm writing the model in the population format. I'm not writing in the format of sample estimated model. So beta to x2, what I'm saying in this model, my hypothesis claim is, null claim is that this is 0. So that in a way, what I'm trying to say that this x1 is not related to y. This is my hypothesis. Are you with me, the class? What is my hypothesis when I say that I'm testing of significance for coefficient? That my coefficient is 0. And I'm testing this with the help of sample data. You can give some more time to it. The testing of significance at the time of coefficient analysis has got this pair of hypotheses in which I'm saying that individual coefficients are equal to 0. And that hypothesis I'm testing with the help of sample data. And either I'll reject or I'll accept the argument. And you know what is, and if you remember last class, I'm drawing it again. I'm particularly drawing it last time. I'll not draw it again. So right now I'll say that beta is equal to 0 is my claim. And I said that I'll be having the rejection reason on both the tails. Rejection reason, these are the acceptance reason. And I'll be estimating my beta. Let's say I'm saying 1 for argument's sake. So either beta 1 is going to fall here or beta 1 is going to fall here. If it is falling here, I'll say that claim of null that beta 1 is equal to 0 is rejected. And if suppose beta 1 falls here, then I'll say that claim that beta 1 is equal to 0 cannot be rejected. The difference between beta 0 and beta 1 is so small that whether it is mathematically different, but statistically I'll assume that it is equal to 0, and I'll not be able to reject the null. That was the whole exercise which I did. And to do that, I'll be using one tool in the computer. Whenever I'm doing using any computer to do the testing of significance, I'll always get p-value. And I gave you one liner. If p-value is, just remember this, if p-value is less than 0.05, reject the null. You just remember this much and this will serve the purpose. Every time whenever we are doing any type of testing of significance, I need to have null and alternate, practically null. And when p-value is less than 0.05, I'll say that null is to be rejected and alternate to be accepted. And if it may be otherwise, if p-value is more than 0.05, I'll say no, I cannot reject the null. I have to accept the null. And practically, when I accept the null, then alternate is going to be rejected. So please pay attention. Don't worry for this story. This story is need not be worried. You don't worry for that. You worry only because we are going to be every time whenever we are running a model, we'll be having whether it is coefficient or model, or for that matter, when we are even doing the diagnostic testing, we'll be doing different type of testing. Every time we will be having one null and we will be having p-value. So null and p-value, null and p-value. We look at, we have the run null, we generate p-value, and we look at the p-value's value, and accordingly we will be either accepting the null or rejecting the null. So practically, the whole exercise of testing of significance will be dependent upon two things only. Testing of significance need two things. Null, you have to be very clear. What is the null in a particular test? And you will be having so many tests. What is the null? And second is what is the p-value? That's it. End of it. You need not worry for anything else. That is the ground reality. I have told you the story so that you should not be completely bereft of theory behind it. So once I have told you the theory, practically I don't want to complicate it, but as a teacher, I need to tell you the story or theory behind it that I have told you. But when it comes to application, I'll be doing this only. I'll be having a null for every situation, looking at the p-value. I'll take a judgment whether to accept the null or to reject the null, and accordingly, I'll be able to take a decision whether these diagnostic testing, but the coefficient model are relevant or not, or meaningful or not. So my whole exercise for testing of significance will be only for these two, null and p-value, nothing else. All of you feel free. You want to discuss theory, please discuss, but we would prefer to stick to my idea. We'll have pair of hypothesis or null, and we'll look at p-value. That's it. Complete discussion. Discussion will be over. Yeah, feel free in asking if you have any doubt. Please go ahead.
Sir, I have a question. Suppose it falls in the acceptance
Done.
region, the
Done.
p-values, and then you are forced to conclude that the null cannot be rejected. Null has to be accepted. Then are you going to replace that variable and search for another variable then?
That is, that will be dependent upon how many variables we have, what is theory behind the building up model. So then again, we go to the basic question of building the model, specification, this issue, parametric stability. So that is again partly science, partly art, and partly literature review, so that we'll be able to understand that for a particular dependent variable, what are the possible independent variables. So a lot of things will go into it. So this question cannot have a flat answer. So in a particular situation, we need to think what are the possible other independent variables. If some particular variable is not significant, what are the other variables which I can take? So I can either use my own mind to think about a new variable, or I can take these help of some previous study. That is what we call literature survey, and accordingly I'll be in a position to find out one or two more variables which may I again test whether they are having the significant value or not, and so that I would like to have a relatively better model. In that case, when the taken significant, the considered independent variables come out to be insignificant or having the beta value equal to 0. Right, Nishan?
Yeah. Okay, sir.
Feel free in asking if you have any question, even you have iota of doubt, feel free in raising the issue. Don't worry for anyone. You are the most important person individually.
Sir,
Yeah.
since you told us then that when we take out null hypothesis, so we get to know that H is accepted because it's below minus 0.05. And then you told that because beta is accepted and x1 will not impact y, which is a dependent factor. So does that mean for that y? So does that mean that y is not equal to? So does that mean that y is not an independent factor for x? I mean, y is not a
Other
dependent.
one, X is not independent variable. X is not impacting Y. If suppose beta 1 comes out to be 0. And let me correct what you have said. Huh? I understood your question. Let me correct. Let me give the right words to that. You know what is happening when I'm testing? This is the model. Huh? This is the model I have. Beta 0 plus beta 1 x1 plus beta 2 x2. This is the model I have. And what I'm saying that I am having null. I'm talking about, let's say, beta 1 only right now. And my null is beta 1 is equal to 0, which is a universal null for testing of any coefficient in regression. So this is pair of hypothesis I have got. Now I'm running the test and I have got p-value related to beta 1. Huh? I have got this p-value. Let me be more clear so that you don't confuse at all. Yeah, look at here. So what I'm saying, I have estimated beta 1 and I have got corresponding p-value. And as you said that, let's say p-value, first of all, p-value will never be negative. Whether we are on the left side, if you remember my discussion in my previous class, I said when the values are on the left side, then we consider that we are calculating the value of p from the minus infinity to here. So as I said that the area between this curve and axis is 1. So at mean, this is 50%. So this is, if I said that it is, if you remember, this is 2.5%, this much, and this much 2.5%. So I said the method to calculate p-value, that suppose for argument's sake, the estimated value in your, as you are talking, it is here. So it means it is more than 2.5%. Let's say for argument's sake, from minus infinity till this point, the area between these 2 points, these 2 lines, let's say for argument's sake, it is let's say 6%. So p-value will be 2 because we are talking about 2 tail, one tail here, one tail here. So we, by default, when we calculate p-value, this is the work which is done by the software for you. Don't you worry. I'm telling you the theory. I'm telling you theory so that you have clarity. But when we use it, we don't worry about so many things in that detail. We practically look at the p-value. Let me complete the discussion. So 2 into 6% will give me 12%. 12% is nothing, 0.12. And if I go by my discussion of p-value, it is less than 0.05, reject the null. 0.12 is not less than 0.05 or not equal to even. It is more than 0.05. It means I can't reject the null. So when I can't reject the null, if you look at, I can't reject the null. So it means I have to accept it. Oh, sorry, I'm spelling the other way around. When I'm saying that this value is 12%, it means I cannot reject. So it means I have to accept. Sorry, I said the other thing. So I have to accept it. So when I say I have to accept it, so I have to take this, that beta 1 p-value is, as I have found, 0.12. I'll say I cannot reject the null. I cannot reject the null. It means practically what is happening, that x1 is not impacting the y. Yeah. Now you can tell me the follow-up question.
So this means that x1 is not an independent factor for y.
It means that x1 is not good enough to tell anything significantly about the dependent variable y. So x1 can be removed. If theory says, literature says, no, it should be, then we'll keep this in the model. But we know that x1 is there in the model. We are considering, but it is not practically or statistically significant. So the impact of x1 on y will be considered statistically insignificant. The term I'm using, insignificant.
Okay, sir. Thank you.
Clear? So gradually you will pick up the language of data sciences or statistics, and you may think that you are a business graduate and you have got nothing to do with data sciences or statistics or econometrics, then you are not thinking in the right way. What happened in business, statistics you are used so often that becomes part of the business language. Okay, we use English language in business, but what we communicate, the content is usually statistics which we are communicating. Whether it is descriptive or inferential, doesn't matter. But we talk statistics only. When we present anything, we talk statistics only. So the language of statistics have to be picked, not today, then later on. So don't worry, if you are new to these terms, very soon, by the end of this semester, you'll find that you're also talking the way I'm talking, or anyone else talks about the business. We all talk in the language of statistics. There's no other language. There's nothing else to be communicated. We have to communicate data or statistics when we talk. Yeah, any other question?
Sir,
Yeah,
you said then p-value is less than 0.05, we reject the null.
correct.
But here it is 0.12. So it
So
is
0.12 is
greater.
much more than 0.05, no?
Yes,
0.05
yes, sir.
and
0.12
0.12
is,
is more than 0.05.
so it is not less than. So we will
Not
not
less.
reject.
Look at here. You know what I said, that if p-value is less than 0.05, reject the null. So if it is other way around, I'm not asking you to cram that statement, but the obvious interpretation is if p-value is not less than 0.05, null cannot be rejected. Are you with me?
Yes, sir.
So when null cannot be rejected, this is exactly what I said, null cannot be rejected. So we accepted that beta 1 is 0. So that's why this discussion that x1 is not statistically impacting the y. With me?
Okay, sir. Yes, sir.
I would appreciate if you have more questions. Ask as many questions as you can, so that when you are asking questions right now, tomorrow it would be much more easy for you. And don't worry for the language. Language means I'm using significance, null, p-value. Don't worry, all will be your language very soon. Wait, if you are a little bit sensitive to communicating your information in an effective way, you have no other choice, and it will become your preferred language. This is the way we talk. Whether it is HR or marketing, these are immaterial. Your background, your functional domain, all are immaterial. When you talk sense, you have to use this language. Yeah.
So we have only calculated estimate values
Yeah.
of coefficient.
Yeah.
So how can we test the actual B1, B2 for significance then?
Your voice is slightly not clear. Please repeat what you have asked. I could not understand. Your voice
Okay.
is not clear.
So we have only calculated the estimated values of coefficient.
We have calculated the estimated value. Perfect.
Okay. So then how can we take the actual values of coefficients, that is B1 and B2, for significance? So like you said that we are doing all this hypothesis testing on B1 and B2, the actual B1 and B2, the
But
final model.
I am testing this beta 1 using sample data. So
Yes.
I'm using sample information to understand whether beta 1 is 0 or not. Just because I do not have population data, so I have to use the sample data. But I will stick to my discussion about the population.
Okay. So we already have the final, the equation, the regression
No,
for.
what
Okay.
we have model for population, because ultimately the weight relationship with height and age are going to be used for population. So
Yes.
my discussion should always confine to population or for population. But when I'm doing this to build the model, to test the model, I have only sample data. So I'm limited by the sample size or the data available for sample. But
So
my
basically,
discussion should always confine about the population.
okay. So basically, we are testing the population model using sample estimated.
Perfect,
Yes.
perfect, perfect. This is
Okay.
exactly, if you look at my language which I'm using, I'm very careful when I say this, that I am testing the population coefficient beta 1 using the sample data. This is exactly, I tried to explain. Yeah, here. I'm testing beta 1. Beta 1 is the population model. But just because I have sample data, so I have no other choice. And I'll tell you one more thing, just because this issue has come from the context. Doing consensus study means taking all the population data is at times faulty because of measurement error. And on the contrary, it has been found that sample study, if sample size is appropriate, is more effective. I repeat myself. All the population data will have no measurement error. On the contrary, when you are using sample data, then accuracy of result is much better, provided you are following all the rules of the way we are talking, and you have got the appropriate sample size.
Okay. So, sir, just one more thing. Then, how do we get the value of B1 then? So do we have it already?
There is no method by which we can actually get the value of B1, beta 1. We can't.
Okay.
We have,
So by using,
hypothetically, I have got all the sample data I can estimate. But as I have said to you, that when you are collecting data for whole population, you are compromising time, you are compromising money, and you are compromising efforts. You can note down these three things: time, money, and efforts. All three are going to be wasted when you are going to go for census type study. Census is done for a different purpose. Government of India have got a census full-time department. But in a practical study, you are going to waste your time, efforts, and money is also going to be wasted. So all these three things, time, efforts, and money, are wasted when you go for census. It is always recommended to go for sample, taking care of these three things.
so basically we are using different samples to arrive at the final value of the coefficient.
No, I didn't say so. But I said that I have one sample. I'm using one
Okay.
sample only to do my study.
Okay. Got it, sir.
If sample is drawn properly, my result will be more or less, within the limitations of analysis, will be accurate.
Okay.
Yes, any other question?
So,
Yeah, Tanushree.
so I did not understand that two-tail thing, like P into 2. Why did you do that?
Look at here, two tail, one tail. At this point, this is enough to understand that the beta 1 may be here or here, because our claim about in the null, we are not saying that beta 1 is more than 0 or less than 0. That is not the claim, but we are saying that beta 1 is 0. So beta 1, when we are testing the significance, we are not bothering whether beta estimate, the sample beta is going to be, or estimated beta 1 is going to be on the left side, on the right side. When we are having this type of situation, when we are not clear whether the discussion is on one side, whether discussion is on beta 1 is more than 0 or beta 1 is less than 0, when this is not the discussion, when we are indifferent to this discussion, we go for two tail. But when we are very certain that we can't go for, let's say, argument say beta 1 more than 0, we only confine to this, then we go for one tail.
Okay, sir.
So situation wise, we take a call, and as and when, because right now we are not doing a general hypothesis testing. What we are doing, we are making use of hypothesis testing for doing the regression analysis. I repeat myself, I'm not teaching hypothesis testing. What I'm discussing, application of hypothesis testing for regression analysis. So for that purpose, as of now, this argument is appropriate. In this context, I'm not worrying whether beta 1 is more than 0 or less than 0. My only context is whether beta 1 is equal to 0 or not. So in this context, this application of two-tailed test is perfect.
Okay, sir. Thank you, sir.
I'm open to more questions. Don't worry. Syllabus have to be completed. That's my problem, my headache, not yours. You just take care of your issues, whether you are clear or not. If you are not clear, please ask. Don't worry for anyone. Don't worry for anything else. Worry for yourself. Yeah, Ramana, you have any questions? Because why is probabilistic? Yeah, what is this? In what context you want to ask? Why is probabilistic?
So this was for when you asked why we are doing further calculations, why we are
Okay,
not stopping at that moment.
okay. I'm open to more questions. I'll appreciate if you ask. I'm in no hurry to take you ahead. I want to spend more time on this so that you are clear.
Sir, I wanted to ask
Yes, Nishant, ask.
another
Yes, Nishant, go ahead. Yeah, we are waiting, Nishant. Yes.
Am I audible, sir?
Yeah, you're audible. Please go ahead.
Okay. I wanted to understand that in where we can practically use this model. So one example I already mentioned about was for demand forecasting. So I was wondering that in within the financial industry, can we use these models for practical purposes? For example, like predicting stock prices, for example, or maybe for option pricing.
Option pricing has got nothing, no use of this model. For option pricing, we need to forecast the volatility. So when you use Black and Scholes model, so volatility can be estimated by one model, which we'll be learning gradually. Volatility models. So probably after midterm, you will have that. And this model, you have 1,000 applications, possible applications. As you said that to forecast the share price. Do you have any idea, Nishant, your portfolio? You understand? CAPM, Arpita has taught to you. CAPM.
We have not done CAPM with Arpita ma'am, but we had done in the caffeine sessions.
So what happened? Let's say CAPM. We are talking about return of a particular security using risk-free rate. I'm just trying to give you quickly and not waste much time. Beta S and RM minus RF. So practically, if you look at that market risk premium, we call it a market risk premium. So what is happening? This is only one, only one factor is there. I can have another model. I'm just a dash, I'm putting it. Let's say I'm calling it beta zero. I'm generalizing RF plus. I've got beta one factor one, beta two factor two, beta 3 factor 3. Practically this is, we call it multi-factor model to go for knowing the value of the or possible return on a particular security. So one of the examples. Even CAPM is practically example of regression analysis. So multi-factor model, you might have heard a term arbitrage pricing theory. That is one, we have got only one. We do not have market, but we have some other, factor. So single factor, but you could have multi-factor model also. I'm trying to give you example which you have just asked related to that. Otherwise, there is no limit to the application of regression analysis. You name any analysis, even volatility model, as I said, you will find that genesis of everything around, practically everything is on regression. Regression is the root of practically any analysis in any data analysis. You name it, I'll tell you whether it is there or not. So clarity of regression is very essential. And problem is not this. Problem is you should have wisdom
Okay, sir.
and courage to apply the concepts. What happened that you guys believe in cramming, clearing the semester. That's it. And whenever you get the occasion, you feel scared to apply the concepts. Okay, you will do some mistake. You take somebody's help and use it. So I have found that 30%, 40% people, or rather less than that, have courage to apply the concepts in real life. So problem is not the concept. Problem is in your courage and wisdom to apply the concepts. You will have plethora of situations where applications can be done. Trust me. You can mark my words. You will realize what I've said. You need courage and wisdom to apply. Concept will not be having any problem. Your ability, your intelligence, your courage. Yes, I'll apply it. Okay, if I do it one, I might commit some mistake, but you can take somebody's help, and eventually, when you apply it only, then you learn it. At one go, this is art. Application of regression, or for that matter, any modeling is art. And art cannot be acquired in one day. You can't cram the art. You acquire the skill, and skill is acquired only when you practice it. So to practice this, practice these skills, you have to look for occasions and you have to apply it. But when you are scared to apply, just because you will do some mistake, you lose the opportunity to acquire these skills. So Nishant, this is much bigger problem. Trust me, what I'm saying. I'm talking. I'm using my experience when I see students get the chance and what they do. So I've made up my. I've got this conclusion that occasions is not the limiting factor. Your wisdom and your courage is the limiting factor. You should be ready to fail. It's not that you should fear to fail. So that's a big hindrance in application of data sciences. Yeah. Any other question? I don't want to move further. I want to waste more time on this so that you have clarity. And hardly I'm finding that 20-30% of you are asking 5-7 students. What about others? I know that others also have issues, but just because you don't, you are not in habit of asking, so you don't want to ask. Please go ahead and ask. Whatever is your doubt, small or big. Yeah. Go ahead.
Sir, can you please, hello sir. Sir, could you please explain more on
Beta part means what exactly you want. Vaibhav, tell me what exactly you want. Tell me.
Hello sir, hello.
Beta, you are talking CAPM beta or normal beta? Normal beta, what happens? Suppose you are, let's say for argument's sake, we have got y is equal to beta 0 plus beta 1, x1 plus beta 2, x2. So beta 1 tells if it is more in value, it is positive or negative. So how x1 is going to, suppose we talk about in the context of x1, then how x1 is going to be related to y. So beta 1 tells whether it is adding positively, negatively, by what value. Suppose 1 unit change is there in x1. Then as per the value of beta 1, it will be decided that how it is going to add to y. So beta 1 value, sign, all becomes very important in the context of how x1 is going to impact dy.
Sir, so is it contextual?
Obviously, when we run a model, we'll get a value. Let's say, here if we look at here, this is the model which we have tested. So what we are interpreting. So what we are saying that this is constant. That is not that meaningful. Let's talk about x1 is height. So what we are saying, suppose somebody, we have we have got some value. Suppose one person you have tested and he has got certain weight, and you suppose change the height by 1 unit. We are measuring the height in meters, so practically we can't change the height by 1 meter. Let's say some fraction we increase. So 0.73 will be, whatever change is there in x1, you multiply that change by 0.73, that much weight will be added. That is the interpretation of beta 1 in this given situation. So as I have different beta value and different sign, accordingly I'll tell you the discussion how this x1 is going to impact the y.
Okay, sir, got it. Thanks.
More questions?
Hello?
Yeah.
So negative beta will mean that there is an inverse relation between the y and
yeah, perfectly all right. Perfectly all right. Let's say for here, as age goes up, what we are finding, x2 is age. You remember? We have taken it. You're with me?
Yes, sir.
X2 is age. What we are finding that as you have, increase in age, let's say one becomes 1 year older, then the optimum weight is going to be 0.26. 1 unit change in weight, age, 0.26. So ideal weight in that case should be lesser. So as you become old, the ideal weight is that you should become lighter. That is the model interpretation.
Okay. Thank you, sir.
ठीक है, 15 minutes, so I'll only finish this discussion, this part of the discussion. Practically, I think I'll be finishing only this significance. Right? Tomorrow or next week, we are meeting every week. I've told Karka to arrange it. So we'll have this coefficients discussion relative importance in next class. I'll confine only to significance of the coefficient. Look at this regression output which we have got. All of you can get this on your laptop. All of you. So I'm giving you time. Run the regression on your laptop. Open Stata. All of you, please do it. I'm giving you 5 minutes. Run Stata on your laptop and tell me whether you have got these coefficients or not. I'm waiting. I'll show you how I have got it. As I start, I'm just not saving it. So I'm starting Stata. You can also follow me if you want. I'll go to file. I have kept my data at a place. My data is at a place. You know, here, this is my data. So this is the path which I'm having. So obviously I know where my file is, and I have told you file should be arranged in this way. First row should, and there should not be any gap. Look at WT, HT. I'm not WT, there is no gap. You know, this is not the right way. Stata will not read it. It will create trouble. So follow the programming language strategy. Good number of your engineers also should probably understand what I'm saying. When you do any programming, you have to take care that no space. So keeping that in mind, this is the way to write the first row name of the variables and this data. I'll go to file, import. This is one of the easiest way to get the data in Stata. And I have already done this last time, so it is saved. Otherwise, you go for browsing and select the file, open, and you ensure that you have selected import first row as variable names. And here we go. You want to check it. Go for summary command, SUM, enter. I've got the data, so everything seems to be perfect so far. I believe all of you are doing this on your own laptop or computer. Yes or no?
Yes, sir.
So this I've got summary. So I'm running regression. Regression is either you write down whole regression or just reg is good enough. Then you first write down the dependent variable. My dependent variable is weight, WT space, independent variable 1, I'm putting HT as first and age as second. And this is the command which I have written in my Stata command window, and I'll go for enter. As I go for enter, I have got this. This output is I'm having. All of you have got this? All of you means all of you?
Yes, sir.
Anyone has got any problem? I can't believe that none of you have got any problem. Some of you surely will have got some problem when you would have run Stata first time. Please share your problem. If you are stuck, you are unable to open file or unable to run regression, please tell me. Tanushi, tell me, what is the problem? Not able to?
So I'm not able to open the Excel sheet on Stata.
So you can use this, go to file, import, Excel.
Mm-hmm.
Are you doing this?
Yes.
And as you open, just browse it. Wherever your file is selected, okay, open it, and then just go for import first row as variable name. You will have it. Try.
Yes, sir. Now I'm able to open the.
Good. Run the regression also.
Okay,
Type
sir.
this command. You know this command is here. This command. Reg is for regression. WT, dependent variables. Then all the independent variables.
Okay, sir.
Enter. You have got the same thing again. Anyone else has got any problem in running the test on Stata? Please share with me. I believe I'm taking this for granted that all of you have got Stata at your end, whether on your laptop or desktop, whatever you are using. All of you are on the same page. All of you have got this output. I am repeating, if anyone has got any problem, please share with me. Okay, look at this output. Look at this output. When I'm doing my first analysis, here what I'm going to do, I'll have a discussion also. I'll not confine myself only to, I'll talk about significance when I'm saying. I'll talk about significance. So I'm just putting some bullet points so that I can systematically talk. So what I'm saying, I'll look at the value of, so here I'll write beta 0. Beta 0 value, I've got how much? Minus 39. Minus 39.0. I'll round it off. It is coming out to be 0.9. Then I've got the value of beta 1, and I'll have beta 2. I will have beta 2 value, and here I'll write the values, whatever is coming, and then I'll do the discussion about significance. I'll do the discussion. Look at here, as I'm getting the coefficient value, I'll be just copying it from here and I'll put it in my Word file, this template. Please pay attention. When I say that I'm just taking the value as it is, I'm taking the unstandardized value. Unstandardized. In my next discussion, next class, I'll talk about coefficient relative importance. I'll talk about standardized coefficients also. So first thing first, right now we are confining only to the unstandardized coefficients and their significance. That's it. So right now I'll write minus 39.09, value of HT, coefficient value of HT 0.73, and then age is having negative minus 0.26. Minus 0.26. All of you are with me so far? All of you are with me? Yeah. Again, as a matter of convention, we have got, these two things also. Please try to understand these two things are nothing, but they are helped in generating the p-value. We will confine our discussion to unstandardized and p-value, but these two are important when you are presenting your information to a learned lot. When people know this like anything, then they would like to have value of SE and T statistics also. What is SE? For time being, please note, SE is the error in estimating this coefficient. So this standard error will have a discussion, what is the error in estimating this? Similarly, SE corresponding to T coefficient will tell what are the errors in estimating this. And for the sake of mathematics, I'll tell unstandardized coefficient divided by SE will give you a value of T. And practically, the value of T will give you the value of P. But we have skipped because we are not interested in complicating the whole thing. But when we are reporting, we have to report smartly. We should report SE. And somebody asked, gradually you will become smart to answer questions of SE and T test also. Don't worry for that. For time being, as of now, don't worry for these additional information which I'm putting in my Excel, in my Word template. Just because it should be there, so it is there. It is not important because ultimately the information which these two are telling is going to be construed with the help of p-values. So no worries. These are there because there are people who are interested in digging it further. You also learn gradually how to dig it further. For timing, not required. Don't worry. We'll confine to what is required at this juncture. For you, coefficient, p-value, as I said, null and p-values are good enough. So if I just copy paste the value, I hope the point is clear. I'm not telling you the story about SE and T statistics in detail. Don't worry, not required. The purpose of them is reflected in p-value itself. Purpose is served by discussion on p-value. Matter ends. I hope it's okay. You want to ask any question on SE and T, I can tell you the answer. So we'll confine to more of application, how to have best model and how to have best interpretation. That's it. The mechanism by which the mechanics involved into it can be ignored, so we'll ignore it. So quickly, let me, I hope all of you are with me. Unless until you say, I'll not move on.
Yes, sir.
Even the last student of this lot is important to me. Tell me if you're not clear, any one of you.
Sir, does the hello, sir?
Yeah, go ahead, go ahead.
Does the unstandardized and t statistics are they analogous to the standard deviation and t value?
Standard deviation is not contextual in this context or testing of hypothesis. Rather, if you understand, I'll tell you the language just for you. We are having a sampling distribution of test statistics. I repeat, we are having a sampling distribution of the test statistics. In this time, test statistics is T statistics. So sampling distribution of sample means are being tested with the help of T statistics. So standard deviation of sampling distribution of T statistics is SE. If you have understood, good. If you have not, please ignore.
Okay, okay, sir.
You meet me offline, I'll give you more mechanics.
Okay,
I don't want to waste classes time. I
okay,
repeat once again, I have a sampling distribution of sample means. I have estimated t-value. So standard error in this case is nothing but the standard deviation of sampling distribution of sample means. Huh? This is enough for this point. You meet me offline, I'll explain to you in detail.
okay,
Right?
okay,
Does
sir.
it make sense what I said? No.
Yes,
Partly
yes,
yes,
I got
partly
it.
no. Okay, 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 good, good. I'm open to more questions. Don't worry. Ask anything, I'll answer. I know these things like, you just tell me any question if you have. So I'm just copy pasting. Look at this 37.56. So I'm completing 37.56. 37.56. 37.56 is the SE of constant H. HT has got 0.21 for height, and for age it is let's say 0.20. 0.20, I've rounded it off. T statistics is also there. For constant it is minus 1.04, minus 1.04. For height it is 3.51, and for age is equal to minus 1.34. If you look at the p-values, p-value, constant p-value is, here it is p-value. If you are not clear, please, p-values will not always be available to you on a platter. You have to figure it out where p-value is. But you will, all the time, you will surely get it whenever you are running any software for data analysis. So this is the p-value in Stata. Is it clear to everyone where the p-value is in Stata? You are with me? Class? So p-value for constant, it is 0.333. So I'll write 0.333. We'll use 4 decimal points when we write p-value. It makes sense. So 0. For HT, p-value is 0.010, 4 points. And then for age, it is 0.221. VIF, I said it is optional as it is written. Don't worry for this for time being. We'll handle it in the future. Don't worry. Yeah, look at this only. This much. So this much, if I use the logic which I was using to explain Bj is equal to 0. So we have got universal pair of hypothesis for testing of significance of coefficient. What is this? H naught colon Bj is equal to 0, and this is Bj is not equal to 0. This is universal pair of hypothesis for testing of significance of coefficient. So if I just take now we'll start noting down some rules. Constant significance we don't test. Class. significance of constant is not tested. So for constant significance, we need not worry. We'll take
So
it
then why are we calculating the p-value for the constant then?
because software calculates this for everyone, and in some advanced situation, we may use it. But as of now, at this level, when whatever we are discussing, there is no point. We are having some advanced situations, advanced type of models where it makes sense to have a significance of a constant also. But in a normal course, in a normal situation, the situation in which we are, constant should not be bothered for significance.
Okay, sir.
So wait, as and when if you guys have any occasion, if I just try to remember, then I don't think so we will be having any occasion. Slightly at the upper level, then we have occasions where we, when we dig it much further, we go into much depth, then only we talk about significance issues of constant. Otherwise, we'll take value of constant on the face value without worrying for the significance of constant. I repeat again to the class, constant or beta zero significance is not tested or it is not seen. It is only the coefficients of independent variable like beta 1 and beta 2 will be taken care of for testing of significance. So one rule you can note down wherever you are noting the things. Second, look at height. All of you are with me? This okay? Constant discussion is over. Now, okay, now we are moving to HT. If we look at HT, so HT is having this pair of hypothesis, beta 1, you call it beta instead of beta j, you call it beta 1. So let's say I'm calling it beta 1 is equal to 0, H naught, H beta 1 is not equal to 0. And I'll look at p-value. P-value in this case is for HT is equal to 0.0100. Is it less than 0.05 or more than 0.05? Class? Less. And what is my rule? Will only cram this thing. Please note it down wherever you are noting. This is something which will cram, and this will remain with you for practically the rest of your life. Whenever you deal with data, this is the rule. P-value, if it is less than 0.05, will say reject the null. So right now what we are finding that p-value is less than 0.05. We will reject the null. What is the null? Null is beta 1 is equal to 0. We'll reject it, we'll accept the alternate that beta 1 is equal to not equal to 0. So we will say that beta 1 is significant. Please pay attention to my language. HT is a significant variable because coefficient attached to HT is significant. It is not equal to 0, rather it is alternate is accepted. So it means beta 1, which is 0.73, is significant, which is not equal to 0. So when I write, I'll write here, I'll write discussion for beta 1. Beta 1 value is 0.73, 0.73. I'll continue my discussion. I'll say HT. I may want to write whole variable name. HT is significantly impacting the weight. Write down, this is the description, this is the way to write. Height is significantly impacting the weight. Class with me? I'm making use of my output template to present the case. And once you fill it, 1 or 2 times, we have 4 more such caselet to handle. By the time you'll be, completely well versed with all the terminology, method, how to write, and then later on you start playing with it also. I'm not saying this is the only way, but this is good enough at this juncture. So we'll learn this, we'll learn how to write the results also. So we'll repeat this for 4 or 5 caselets, and then you will master it on your own. So let me complete the discussion for beta 2. Beta 2 value is minus 0.26. But look at this. Look at the output. Age is having a p-value of 0.221. Is it more than 0.05 or less than 0.05? It is more than 0.05. It is more than 0.05. So I'll go back to my rule. My rule is simple. P value is less than 0.05, reject the null. If this is not the case, then do not reject the null. So we will go back and we'll write down, if we want to write here, we'll say age variable is not significant. We'll also, consolidate the statement, will say the null of age coefficient equal to 0 cannot be rejected. This I'm writing. So now this is my whole discussion. So I'm saying so I'm having this discussion that my beta 1 and beta 2 age variable is not significant. The null of age coefficient equal to 0 cannot be rejected. It means age is not impacting weight. Ash, are you with me? Here's one more note. When I say note, it means you should note it wherever you note. We do not use this language of accepting the null. Rather, we'll say we cannot reject. We have to follow certain norms. It is wrong to say that null is accepted. No, we call it null cannot be rejected. So just because we cannot reject, so we'll say accept. So for alternate, same thing, we'll say, for alternate we can say, but for null, it is wrong to say that we have accepted the null. Either we reject the null or we do not reject the null. So right now what we are saying that we cannot reject the null. So this is right to say we cannot reject the null. So that's why the null of age coefficient equal to 0 cannot be rejected. Please mark my words which I am using to represent to present the data or present the analysis. You're clear? So don't say accept or reject the null, rather say null cannot be rejected when it is not rejected. So here I'd like to close. Again, whatever we have discussed, that will be available to you in the class, Google Classroom to you up to this point. Anyone has got any question you can ask, or you are most welcome to have any question even after the class. Just inform me on my mobile through WhatsApp. We'll talk. Any question you have? Immediate question? ठीक है, so we'll close it. We'll meet again next week. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.